Hi chemistry students, and welcome to my 90-second chemistry. I'm Rob Gilliland. We're going to be looking at mass spectrums and how to interpret them. This one's for A-level students. A mass spectrum can be used to determine the number of isotopes and their relative abundance in a sample, or to work out the relative molecular mass of a compound. We're going to focus on interpreting a mass spectrum for identifying the isotopes and their abundance in an element. Look at the example spectrum below. On the x-axis, mass charge ratio, m/z, and on the y-axis, you've got the relative abundance. What's the x-axis actually showing us? The mass charge ratio could be thought of as the mass of each ion, as each ion has a 1+ charge. Think back to that time of flight spectrometry. How long it took the particle to fly through that flight tube is determined by its mass, because all of the ions were given the same kinetic energy. Next, we've got the y-axis. The abundance is calculated by the isotope hitting the detector, gaining electrons and creating a current. That current is directly proportional to the number of ions that hit it. This spectrum here is for chlorine. Chlorine has two isotopes, chlorine-35 and chlorine-37. Now, because they've got different masses, they would have hit the detector at different times. This would have given us different peaks for the mass charge ratio. Secondly, there's different amounts of each of those two isotopes, 37 and 35, in the sample. It's a ratio of about 3:1. That means 3 times as many ions for 35 hit the detector, producing a current 3 times the size of the current for chlorine-37. If you found that useful and enjoyed it, please like and follow. And if you're interested in private tuition, please look at my website in the description. Thank you.